In this instructional video, we'll be looking at different ways we can store data within a computer. This is also known as data types. If you're studying the C for Engineers subject, you'll do a similar sort of thing in that subject as well. Now, up till now, anytime we've created a variable when we wanted to store some data, we've used an integer or an int. So when we write something like int I, we're declaring an integer called I. A couple of things about integers. Firstly, they can only store whole numbers, so no decimal places. And secondly, they use 16 bits to store the actual data in memory, which effectively limits the size of the number that we can actually store in them. Well, we'll talk about those sizes in a moment, but there's some other data types that we can use as well, depending on if we want to represent larger or smaller numbers. Here's the different ones here. If we only want to represent small numbers, we've got chars, or otherwise known as characters. These are 8 bits and allow us to represent from minus 128 to plus 127. In this case, if you add 1 to the 127, it brings you back down to minus 128, so they roll over at the end. We have our ints that we've been using quite a bit in the labs. We have long ints, so instead of having 16 bits, we have 32 bits, which means the numbers that we can store in these long ints are much, much larger. We also have floats and doubles if we want to store large numbers which have decimal places associated with them. We can use these numbers as well. But the thing to be aware of is they take up extra room in memory, so they'll slow down any processing that we're actually performing. Now, by default, these numbers are what we call signed, which means that they can represent positive and negative numbers. The way we represent these signed numbers is the top bit is what's called the sign bit, which represents whether it's a positive or a negative number. So if the sign bit is 0, it's a positive number. If the sign bit happens to be 1, it's a negative number. Now, if we're only representing, or if we're only interested in representing positive numbers, we can make the number an unsigned number, which gives us a larger positive range to actually represent numbers at, but means that we can't actually represent negative numbers because the sign bit's used to actually represent the number rather than the sign of the number. So, for example, our signed character can represent numbers from minus 128 to 127. Our unsigned character represents numbers from 0 to 255. So, same number of discrete numbers that we're actually representing, but only positive numbers now because it's an unsigned character. By default, whenever we declare one of these variables, a character or an integer or anything like that, they're all signed. If we want to make it unsigned, we need to put the word unsigned before the number when we're declaring it. Here's a few examples. So if we want to declare a character, a signed character, we say char character 1 and we set it to 0, default condition, an initial condition. It's exactly the same in practice as saying signed char character 2 equals 0. Then if we want to do it unsigned, we say unsigned char character 3. So we have the options there. One thing that might be useful is to work out what the largest number that we can represent is in a particular variable. The way we do this is for a signed number, we can represent from minus 2 to the power of n minus 1, where n is the number of bits, so for an integer it's 16. That's the minimum number it can represent, to 2 to the power of n minus 1 minus 1. So for an integer, for example, we've got minus 2 to the power of 16 minus 1, so minus 2 to the power of 15 gives us minus 32,768. And on the positive side, 2 to the power of 15 minus 1 gives us 32,767. For an unsigned one, the smallest number that we can represent is 0. The largest number that we can represent is 2 to the power of n minus 1. So for an integer, we say 2 to the power of